Question 10, we're told that the transformation matrix A, which is 0, -1, 1, 0, represents a rotation of 90 degrees anticlockwise about the origin. The transformation B, which is 0, -1, -1, 0, represents a reflection in the straight line with equation y is equal to -x. We're to write the coordinates of what P prime, the image of the point P, which is 7, 11, after it undergoes a rotation of 90 degrees anticlockwise about the origin. So the in this case, A multiplied by P would give me P prime. A is 0, -1, 1, 0, multiplied by P, and P is what? 7, 11. And this will give me P prime. P prime, well, you can multiply it if you want, but I know what this matrix does. What this matrix does is it interchanges. Well, let's multiply it. 0 times 7 is 0. -1 times 11 is -11. Now, bottom row, -1 times 7 is 7, and 0 times 11 is 0. So this becomes -11, 7. And so P under A, P, which is what? 7, 11, under A becomes P prime, which is -11, 7. So multiplying it doesn't hurt. So essentially what this transformation does is that it switches the coordinates and change the sign of the x coordinate. All right, it says T is the combined transformation A followed by B. Determine the elements of the matrix representing the transformation T. So T is what? A followed by B. So it means that T would be BA. So if to get the matrix that represents the combined transformation A followed by B, you're going to multiply the two matrices, but you're going to put the last matrix first and the first matrix last when you multiply them. So this is going to be B, which is what? 0, -1, -1, 0, multiply by A, which is 0, -1, 1, 0. Let's multiply the two matrices. 0 times 0 is 0. -1 times 1 is -1. 0 times -1 is 0. And -1 times 0 is 0. -1 times 0 is 0. 0 times 1 is also 0. -1 times -1 is 1. And 0 times 0 is 0. All I did was multiply the two matrices. And the combined matrix T would be -1, 0, 0, 1. All right. Now we're asked to describe geometrically the transformation represented by T. All right, so T, now what T does to a point is this. Under T, the point X, Y, under T is going to become the point -X, Y. So the only thing T does is that it changes the sign of the X coordinate. And the transformation that actually does that changes the sign of the X coordinate, is a reflection in the Y axis. So T is a reflection in the y-axis. All right, moving on. B says the 2x2 matrix C is defined in terms of a scalar constant K by C being the matrix 3K, 6, 4. We're to determine the value of K given that the matrix C is singular. Now, if a matrix is singular, its determinant is equal to 0. So the determinant of C, you're going to multiply the 3 times the 4. So it's 3 times 4 minus K times 6. And this would be, which is equal to what? 0. So if a matrix is singular, its determinant is equal to 0. So therefore, what we have is what? 12 minus 6K is equal to 0. We have 12 is equal to 6K. Divide both sides by 6. And we are going to get K is equal to 2. All right, so C, if C is a singular matrix, the constant K would be equal to 2. All right, C, the vector part of the question says, in the diagram below, O is the origin. OX is, the vector OX is U, the vector OY is V. OX and OY are extended so that X and Y are the midpoints of OA and OB. All right, so X is the midpoint. It means that the vector XA is also U, and the vector YB is also V. We're to express the vector BX in terms of U and V. So the vector BX is this vector here. So this is the vector BX. Now, using the triangle of vectors, the vector BX would be equal to BO plus OX. Now, OB would be 2V, so BO would be minus 2V, plus OX, which is U. Put in the positive one first. This is U minus 2V. Next, we need the vector BM. All right. Given that YA and BX intersect at M, so we're told that YA and BX intersect at M. So this is M. What else are we told? We're told that BM is equal to 2mx. BM is equal to 2mx. So this is 2 and this is 1. All right. What else? We're asked now to find BM. All right, so if we're finding BM, BM would be equal to BY. Oh, BM is actually 2/3 of BX. So let's go from that angle. BM is 2/3 of BX. So this is 2/3 of U minus 2V. Using a vector method, show that YM, the ratio YM to YA is 1 to 3. YM to YA is 1 to 3. The real YM to YA is 1 to 3. YM to YA is 1 to 3. Show that the ratio YM to YA is 1 to 3. YM to YA. So let's find YM and YA. YM would be equal to YB plus BM. YM is equal to YB plus BM. I think this would be equal to what? This is what? V plus, good. So this is V plus 2/3 of U minus 2V. If we simplify this, LCM 3, this into this, 1 into 3 is 3 times V is 3V. 3 into 3 is 1. This is 2 into U minus 2V. This is going to be equal to 3V plus 2U minus 4V. This is equal to 2U minus V over 3. It's 1/3 of 2U minus V. The next thing we need to find is YA. YA would be YO plus OA. This is YO plus OA. I think this is minus V plus 2U. Put in the positive first, we have 2U minus V. So YM to YA would be 1/3 2U minus V to 2U minus V. If I multiply both sides by 3, I'm going to get 3 times 1/3 2U minus V to 3 2U minus V. Now, if I divide both sides by what? 2U minus V. I'm going to end up with 1 to 3. We're asked to show that YM to YA is 1 to 3, and I've just done so.